Question 21 asks us to prove that 2 cos x plus 2 cos squared x over sine 2x equals sine x over 1 minus cos x. And so what I'm going to do here is start with the left side of the equation, which I'll rewrite here. It's 2 cos x plus 2 cos squared x over sine 2x, and try to make this look like the right side of the equation, which is sine x for 1 minus cos x. And so if we can get this expression through algebra and trig identities to be sine x over 1 minus cos x, then we've proven that this equation is true. So the first thing I'm going to do, working with the left side of the equation, is to factor out a 2 cos x from the top of the fraction. So factoring out 2 cos x leaves us with 1 plus cos x on the top. And on the bottom, what I'm going to do is use one of the identities on the formula sheet, which is the double angle identity. And I'm just going to write this on the side here to remind you guys, one of the double angle identities is that sine 2 theta equals 2 sine theta cos theta. So on the bottom of the fraction here we have sine 2x, and I'm going to replace it with 2 sine x cos x. All right, and so now what we can do is we have a cos x, or 2 cos x on the top of the equation, 2 cos x on the bottom of the equation, and these can cancel out. So we're left with 1 plus cos x on the top and a sine x on the bottom. And the next thing I'm going to do to rework this a little bit is multiply this by sine x over sine x, which is just equal to 1. And on the top of the fraction, what that gives us, I'm actually going to not multiply it in and leave it as sine x times 1 plus cos x. We'll see why that works out a bit better later. On the bottom, what we get is sine squared x. Okay, and so now what I want to do, I'm going to leave the top the same, plus cos x, and on the bottom of the fraction, what I want to use here is the Pythagorean identity, which says that sine squared theta plus cos squared theta equals 1. And if we rearrange this a little bit by subtracting cos squared theta, we get sine squared theta equals 1 minus cos squared theta. And so I can replace this sine squared x with 1 minus cos squared x. Okay, and now what we have on the bottom of this fraction here is a difference of squares. So I'm going to factor that out, and when we do that, what we get is 1 plus cos x, 1 minus cos x. We can see that now on the top of our fraction we have a 1 plus cos x, and on the bottom we also have a 1 plus cos x, so these can cancel out. What we're left with is sine x on the top and 1 minus cos x on the bottom. And that's what we have on the right side of our equation. So yes, we've proved this.